Hello kids, in today's class we are going to learn the concept of area which we have already done in our previous grades. So area is the region which is enclosed in a closed surface. Okay, so if I take example of any figure, let me take any shape, being it a triangle, being it a circle, or you can take any figure you want, any shape, right? I am taking this figure here, or any shape. I'm taking a leaf also. Let us take a leaf, okay? Or any irregular shape. Let's say I'm taking this shape here. So what is the area? First thing is the shape should be closed. It should be a closed figure. Then area is the region which is enclosed in this figure. So in this closed figure, this particular region is the area, this entire region. This represents the area. And perimeter, we have already done. What is perimeter? Perimeter represents the boundary of any closed figure. So if I say what is the perimeter of this, I am marking the perimeter in red. This the boundary, the extreme boundary here. This represents the perimeter of triangle, perimeter of circle, and perimeter of all the given shapes. This red is the perimeter. And what is the area? Area is the region enclosed inside the closed figure. So the one which I have shaded here inside in black, this all it represents the area. Okay, now we have also learned what is the area of a triangle, what is the area of rectangle or square in the previous grade. So let us write it here also. What is the area of square? Area of a square is side, one side multiply with the other side, that is length of one side multiplied with the length of another side. This is the area of a square. Also, I'm drawing it here for you again. Let us take a square, and we know that all the sides of a square are equal. Okay, this is one side, this is second, third, and fourth. All these are the sides, and the property of a square is that all the sides of a square are equal. Now what is the area of the square? I am representing area with A. So the area of the square is product of two sides. Okay, that is side into side. So if I say that the side of a square is 2 centimeter and you have to find the area. If I'm saying the length of the side of a square is 2 centimeter, length of side of a square is 2 centimeter and we have to find the area, then this is simple. It is side multiplied with side. So 2 multiply with 2, which is equal to 4 square centimeters, or you can also write it as 4 centimeter squares or 4 centimeter square. You can pick any one of these. Okay, but we have to always mention the units. Next one, we have area of a rectangle. Also, we know that what is the property of a rectangle? The opposite sides of a rectangle are equal to each other. And a rectangle has a length and a width, which we also call as breadth, right? And what is the area of a rectangle? We have learned this. Let me take one rectangle here. This side represents the length, L. This side represents the breadth, B. And what is the area? Area is L multiplied with B. This is the area of rectangle. Yes. And similarly, we have area of triangle also. And area of triangle is, let's say we have a triangle, this one. Okay, let me draw a bigger triangle. So area of triangle is equal to 1 by 2 of base, which is this one, multiplied with the height, and height is this one. This is the height, h, half b into h. And similarly here, area of rectangle is length multiplied with the breadth. So these are the formulas which we already know. So now let's see. We have this example. A floor is 5 meter long and 4 meter wide. And then a square carpet of sides 3 meter is laid on the floor. Find the area of the floor that is not carpeted. So what it is saying is that we have a floor with the dimension of 5 meter length, that this length is 5 meters and it is 4 meter wide. This breadth is 4 meter. So we can see this is in the form of a rectangle, right? Now a square carpet of side 3 meter is laid on the floor. What it is saying is that a square carpet, it's a square carpet of sides 3 meters is laid on the floor, and we have to find the area of the floor that is not carpeted. So that means the area which is not carpeted, which is remained as is, which I am highlighting in red here. We have to find this area. So kids, how we can find this? This is very easy. We have this as the outer rectangle. If we subtract the area of this square from the rectangle, we will get the area which is not carpeted, right? So let me first write down the area of the rectangular floor. Okay, so rectangular floor, which is equal to length into breadth, that is 5 into 4, 20 square meters. This is the area of rectangular floor. Now next we have to find the area of square carpet. Since it's a square, what is the formula of area of a square? That is side square. That means 3 into 3, which will give us 9 square meter. This is the area occupied by the carpet. Now what we have to find here is find the area of the floor which is non-carpeted. So I am writing here non-carpeted area is equal to area of rectangle minus the area of square carpet, which is 11 square centimeters. Okay, this is equal to 11 square centimeter. Or let me write it like this, 11 meter square. This is done. So this is how we have to do this question. Next we have 4 square flower beds, each of side 4 meter, are in 4 corners on a piece of land 12 meter long and 10 meter wide. So what it is saying here is that we have a piece of land such that it is 12 meter long and 10 meter wide, and on the 4 corners of this we have a square garden, right? Or you can say a square flower bed on the 4 sides of it each, and this is in the form of a square. These flower beds, they are in the form of a square. Their length is the length of the side is 4 meter. All of them, they have same length of their sides and all of them are squares. Now what we have to find is find the area of remaining part of land. So again we have to find the area, this one which is remaining. Again what we have to do, we have to find the area of rectangle first, that is the outer area. So I'm writing here area of rectangular land is 12 multiplied by 10, 120 meters square. And now area of 1 square bed. This is equal to what? Side square, that is 4 into 4. This will give us 16 meters square. This is area of 1 square bed. Now area of 4 square beds will be equal to what? This will be equal to this 16, right? Multiply area of 1 into 4 we have to do. So 16 multiplied by 4 will give us 64. This is equal to 64 meters square. So we have the outer area, we have the total area of rectangle, we have the area of these 4 square beds also. Now what we have to find? The remaining area. So remaining area is, we have to subtract the area of these square beds from the area of rectangle, that is 120 minus 64, which is nearly 56 meter square. So This is how we have to do this. Okay. Next we have this, figure it out. So let's go through it. Area of a rectangular garden is garden 25-meter long is this. So question number 1, what it says is that there is a rectangular garden and area of garden of the rectangular garden is 300 square meters. Okay, this is the area of garden and length of one side, length of garden I'm writing here is 25 meter. What is the width of the garden? We have to find the value of width. What is width? We know the formula that area of a rectangle is equal to length multiplied with the breadth. Area is given to us, this is 300. Length is given to us as 25 and we have to find the breadth. So what we will do? We will take this 25 here. So when we will take this 25 across the is equal to sign, this multiplication is going to change to division. Okay. So what we will have? We will have 300 divided with 25. So this is equal to 12. Okay. So that means the breadth is equal to 12 meters. Easy. This is very easy questions. Okay. Let's go to question number 2 here. So question number 2 is, what is the cost of tiling a rectangular plot of land 500-meter long and 200-meter wide? So here I'm taking a rectangle first. We have a plot, this one, whose length is 500 meters, this one, and it is 200-meter wide. Okay, and now what we have to do is we have to put tiles here inside. So that means this whole area needs to be covered with tiles. Okay, this is first thing. And then what we have to do is we have to find the cost of tiling this at the rate of rupees 8 per 100 square meters. Okay, so we have to find that if we have to tile this whole area, and that has to be done at the rate of rupees 8 per 100 square meters. Okay, for 1 square meter, this is the rate. Then what will be the rate of this entire area? So for that, what we have to do? We have to first find the area of this land. Okay, so I'm writing here area of rectangular plot. This area is length into breadth. That is L into B, 500 into 200, which is equal to 1 lakh square meter. This is the entire area of this rectangular plot. Now what has to be done? It has to be tiled. How? The rate of tiling is for 1 square meter, it is rupees 8 per 100 square meter. So the total cost will be the entire land, 1, 2, 3, 4, 5, it's 1 lakh multiplied with the cost of rupees 8 per square meter. So this gone, this is gone. Answer is rupees 8,000. Okay, so this is the cost of tiling the plot. How we have done? We have to find the area first where the tiling needs to be done, and then the cost of rupees 8 per 100 square meter is given to us, and we need to find out the total cost, which we can multiply and find out. Okay, this is easy. Next question, kid, is a rectangular coconut grove is 100-meter long and 50-meter wide. Okay, let me just erase it fast and we can draw it here now. Question number 3 is a rectangular coconut grove. This one, it is 100-meter long, its length is 100 meter and it is 50 meter wide. This is 50 meter. If each coconut tree requires 25 square meter, what is the maximum number of trees that can be planted in this grove? This I'm giving you as a homework. Very easy. What we have to find out? First of all, just find out the entire area. Okay, so once we know the entire area will be what? 100 into 50. This will be your entire area. Now, if each coconut tree requires 25 square meter of space, now one space occupied by one tree is 25 square meter. This is the space occupied by one tree, and we have to find the number of trees which can be grown in this area. So this is simple. We have the area of total land and we know how much space is taken by one single tree. So this calculation is going to give us the maximum number of trees that can be planted here. So if we do it straight away, this is 25 into 1, this is 2. Nearly 200 trees can be easily grown here. Okay, so this also we have covered. It's not a homework now. Next, okay, by splitting the following figures into rectangles, find their areas. All measures are given here in meters. Okay, so this is easy, kids. Let us first pick this figure A and let us split it into rectangles. So first one, I can write this one as here. Sorry, this is one rectangle. This one is another rectangle. This one is third and this is fourth. So if you see, we have one rectangle, second rectangle, third rectangle and fourth rectangle here. And we have all the measurements given to us. So for the first one, if we see here, that what is the measurement of this? This is length. This is breadth, sorry. This one is the breadth of this one and this one is the length of this one. Okay, so if you see this figure, I'm writing it here, question number 4, and for question number 4, A part, I'm just writing the areas. For the first one, area, it will be L into B. Breadth is given to us as 1 and length, this one, this is given as 3. This total is given as 3 and this is nearly 2. So this will be 1 only. So 1 into, wait. Yeah, now it's fine. So this is, I'm marking this as figure first, figure second, figure third, and figure fourth. Okay, let's do it this way. So for the first figure, what we have is L into B. L is the length which is here given to us. This is nearly equivalent to 1 into 2, which is equal to 2 square meters. All these answers, they are in meters. So this is square meters. I am writing it as square meter. Coming to figure number second, what we have is again this breadth L into B, where this is the entire length. This one which was given to us as 3 and this is 2. So length into breadth. I am writing 6 here, 6 square meter. Coming to the third rectangle. This complete is the third rectangle given to us. So if you see this one here, we have, till here we have 2 and then after this we have 4 here. So this is equivalent to 6 multiplied by, this one is complete 4, this is 3. So that means this should be 1. Again, this is 6 square meters. And the last one here is fourth. This one figure. Here what we have is length into breadth. So length here, this one, the complete for 4, this is 3. So we have 3 into 3, which is equal to 9 square meters. So these are the different figures given to us and you combine them, you will get it 2 plus 6 plus 6 plus 9, which is equivalent to 9 plus 2 is 11 plus 6 is 17 plus 6 is 23, nearly 23 square meter. This is the dimension. Now, if we take this figure, the other one, we can split it like this. Kids, I'm giving this as a homework. It's very easy. You just split it like this. This is one rectangle. Split it like this. We'll have the another rectangle. This one. This complete is 3. For this, if I take this triangle, sorry, this rectangle, this is 3 and this is 1. Same, this is 3 and this is 1. We can find out the area, right? And if we see this one inside, the smaller one, we know that this is 1 and this is 3. Okay, so find out the area of these 3 different rectangles and add them. Now, let us move further. We have these two figures. Look at the figures below and guess which of them has a larger area. So kids, if you see this, it is very much visible that the part B here, it has the greater area, right? Next, we have another method. To estimate the area, we can trace the shape on a piece of transparent paper and place the same on a piece of squared graph paper as shown here. So what they are saying is that if we have any type of figure, the figure should be closed. So any type of closed figure where we have to find out the area, and what we can do is we can put that particular figure on the squared graph paper. So squared graph paper is nothing but it's a graph paper where we have squares of equal dimensions, and mostly they represent one square unit. Okay, so and then follow the below conventions. So these are the conventions which we can use to find the shape of any figure on a square graph paper. Okay, so let us go through the conventions. The area of one full small square of the squared or graph paper is taken as one square unit. So that means if we take one complete square anywhere here, the area is taken as the area of the one square is taken as one square unit. Okay. Next, ignore the portions of the area that are less than half a square. So there may be certain areas which represent less than half of a square. We have to ignore those. Third, if more than half of a square is in region, just count it as one. So if there are certain squares which represent more than half of the square, take them as one. If it is less than half of the square, just ignore them, and if they are equal, just take them as half. Okay, yeah. And then if there is a square which where it is taking exactly the half square, then we have to count it as half. So these are the four things which we have to keep in mind. If we are taking complete square, we will consider it as one square unit. If it is half, consider half. If it is more than half, take it as one. If it is less than half, ignore it. Okay, so using all these conventions, let us now begin finding the area of these figures. Okay, let us take two figures here and two will take as a homework. Okay, so I am going to take the second figure first. So what I am going to do here is I am going to draw squares and measure the number of squares. So if I see here, starting from here, this represent half square. I am writing half, plus this represent one square, complete one, plus another half, this also half. Since they are exactly half, that's why I'm writing half. Okay, coming here, this is half, this is complete one, and this is complete one. So to this side again we have same thing, half, then this complete one and one more one, right? So this covers this area. Now coming to this side, one half, one full square, one full square. So one half, one full square, one full square. Now to the other side, one half, one full and one more half. One half, one full and one more half. So adding this is going to give me the area. Let us first add the ones. 1, 2, 3, 4, 5, 6. So these are complete ones. We have 1, 2, 3, 4, 5, 6. Now the half. This half plus this half will make 1, right? This half plus this half will make one more one. So it is 2, and this one more. So this is 3. 6 plus 3. This is equal to 9 square units. This particular figure is 9 square units. Easy. Now let me also take the last one, n. This says 1, 2, 3, 4. So 4 full squares I am writing directly. And then if you see here, half, and half. 1, 2, 3, 4, 5, 6. 6 halves. I can write 6 half as 6 multiplied with half also, right? So plus now these halves are covered. Coming back to full squares, 1, 2, 3, 1, 2, 3 and 4 again. So this is 4 plus 4, 8. And now let us solve this. 2 into 1, 2 into 3. This is 3. 8 plus 3 will give me 11 square units. Okay, easy. We understood that how we have to measure it. If the square is complete, take the complete one. If it is half, then take it as half. If it is more than half, take it as 1. Less than half, ignore it. So this is how we can find out the area of these closed shapes. Now, the first one and the third one are very easy and they are homework for you. Now, let us go further in this chapter. Okay, so why is area generally measured using squares? So what they are saying is that let's say if we have any area, so what would we prefer to measure that area as inside that area, whether we will use circles or we will use the squares or rectangles, which one is more preferable and why? So kids, understand this. If we are going to use the circles here, then this area that is between the circles, this will be wasted and we will not be able to measure this area, right? But if we will use any square or any rectangle for measurement, then we will not get gaps here and the area will be perfectly measured. So that's the reason we generally go for using, we use these, the squares or rectangles. Now, next we have, let's explore another activity. On a square grid paper, so I have taken a square grid paper here. One square is equal to one square unit, which we saw. Now, make as many rectangles as you can whose length and width are a whole number of units such that area of a rectangle is 24 units. So what we have to do here is, we have to draw the rectangles here whose length and breadth can be different. That means we have to draw different rectangles here with different length and breadth measurements, but their area should be same. Okay, and what should be the area? 64 square units. So before we draw, let us first try to break down answer 1. I'm writing answer 1 here. Let us try to break down 24 into different parts. Since we know that area of a rectangle is equal to length into breadth. Okay, and we want to make different rectangles here such that length and breadth can vary but the area should be same. So the best is, let us try to use the factors of 24. First way to make it is 1 in 24 multiply with 1, where length can be 24 and breadth can be 1. Next, we can make it as, for 24, we can make it as 12 into 2, right? And also, we can make it as 8 into 3, right? And then 6 into 4. I'm writing here. So these are the different ways we can make this triangle. Now let us try to do the first one. Try to pick the first one, 24 into 1. So we have to pick 24 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Wait. 17, 18, 19. So maybe 20. Okay. I'm making more. Wait. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So maybe more I'm drawing here. Just give me a time. Let me align it properly. So this is 21, 22, 23 and 24. So similarly, we'll have like this. So now if I want to make a triangle here of length 24, okay, of length 24, and width as 20 as 1. So this is 1 and this entire will be 24 because I am taking 24 squares here. So this will represent a triangle, this triangle first, 24, where the dimensions are 24 multiplied with 1. Next I am taking 12 into 2. So 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. This and 2. So this will represent 12 multiplied with 2 and 12 here. Next one we have 8 into 3. So 1, 2, 3, 4, 5, 6, 7, 8 and 3. So this is 8 into 3. Okay. And the last one we have 6 into 4. So for 6 into 4, I'm drawing here 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Plus 4, 1, 2, 3 and 4. So you understood how I am drawing it. I am taking 1 square unit measurement and then drawing it. So this is 6, this is 4, we have 1, 2, 3, 4 here and 6 squares here. Similarly, we have 8 squares in length here and 3 squares in width here. For above, we have 12 in length and 2 in width. And for the topmost, we have 24 in length and 1 in the breadth here. Okay, so this is how we can make it. Now, which rectangle has the greatest perimeter? So let us find the perimeter here. We know that what is the formula for perimeter of a rectangle? It is P. P is representing the perimeter 2 into L plus B. Okay, so let us find for the individual one. So this is 2, length to 24 into 1 is 24 plus 1, that is 25. 25, this will make 25, multiply by 2, 50. Next, this one, again 2, L plus B, that is 12 plus 2, 14. 14 into 2, 28. Next, 2 into 8 plus 3. 8 plus 3 is 11 into 2 is 22. And the last one is 2 into 6 plus 4. 6 plus 4 is 10 into 2, 20. So all these are in square units first of all. So I'm writing square units, everywhere. Sorry, these are the perimeters. So they are not in square units, kids. Areas in square units. This is in meters only. 20 meters. Let's say if it is in meters or units, you can write. Okay, so if we go through all these, we can very well see that the rectangle which has the greatest perimeter is the first one. It has the dimension, length is 24 and width, or you can say breadth, is 1 unit, 1 square unit. And which has the least perimeter? So least perimeter has this one, where length is equal to 6 and breadth is equal to 4. Okay, so this is how we have to do this question. Similar to this, we have another question here, kids, where if you take a rectangle of area 32 square meter, what will be your answers be? So this I am giving you as a homework. I am just helping you here to find out the factors, so that you can draw it here. C. For C, what we have is 32. Same thing you have to do here for 32. Now, that area should be 32. And again, it's a rectangular area only. Yes. So, let us break this 32 into different factors, using different factors. First one is 32 into 1, where this is length, this is breadth. Next one, we have 16 into 2. Not with 3, it's not a 3 is not a factor of 32. We have 4. So we have 8 into 4 here. Right? These are 3. After that, what we have? 4 is a factor, 5 is not a factor, 6 is also not a factor, 7 is not a factor, 8 we have already covered. So these 3 are the only different type of rectangles measurements we can have here. Now let us find the perimeter of these. What is the perimeter of first one? This is 2, 32 plus 1, 33. That is 66. units. Coming to the second one, this will be 2. 16 plus 2, that is 18 into 2 is 36 units here. The last one we have 2 into 8 plus 4. 8 plus 4 is 12. 12 into 2 is 24. So the rectangle with the greatest perimeter is this one, smallest perimeter is this one, and 3 rectangles are possible here. I hope this is clear, and now you know that how we have to draw it. So this drawing part is a homework for you, and I will see you all in the next class now, and we will move further in this chapter. Thank you.